There's evidence that hackers are trying to compromise the private information of system users and may be trying to bring down the service. That brings up two important issues. The first issue is, how does the system keep users' data private? And the second issue is, how does the system protect against a denial of service attack? Identify the protections already in place that are provided by the platform by default, then consider additional design changes that could provide additional protections.
So let's go ahead and take a look at our photo service. In this case, we're so popular that now somebody is a little miffed at us and trying to attack our service. So we have to ask ourselves, is user privacy at risk? Could a denial of service actually happen? Right? Or maybe we're not being attacked, we're just preparing for this. So hackers do attack. So during a routine audit, evidence was found in the logs that hackers are trying to gain access to the service. So we have to ask ourselves, what protections are already in place due to the choice of platform or the current design? Are there any additional steps that we can take to make sure data is not already compromised? Now, what other design challenges are we going to come across to reduce that attack surface? How do we actually start creating that layered scenario which we can potentially isolate and disrupt any potential hackers? Well, again, let's take a look at our existing architecture. We are trying to identify from a business standpoint any security vulnerabilities. Our goal is to provide defense against hackers compromising privacy. Notice here, there's really nothing that calls out security. We do have some built-in security with the network, our HTTP global load balancing and cloud load balancing, but we really haven't specified any internal IP addresses, private networks, firewalls, security, etc. So, first thing that we want to do is we want to lock down the front end. Now, granted, you would probably already do this, but again, let's build and design and make sure we accommodate for this because obviously we can't even open up ports without opening up firewall rules. In fact, we put up a firewall by default anytime you create a virtual machine. But in this case, that is something that we would want to identify that's security related, as well as we already inherit those built-in network protections because of these global load balancers. So we're protected against some of the more major denial of service attacks. So if a denial of service attack does come in, we have to ask ourselves, well, what processes are in place to deal with it? How do we handle any immediate situations? So we should have a game plan. And then how do we continue to evolve this design to protect against future denial of service attacks? So in this case here, we have a denial of service attack. So one of the first things we want to take advantage of is we're already using the network, so we can turn on Google Cloud CDN. So what this will do is take a majority of our thumbnail and static data that's being pulled from the network, and we can cache that at the edge. So this will be distributed to the over 120 plus locations around the world, as well as take advantage, if you haven't already, of Google Cloud DNS. Again, with 100% uptime, they're not going to be able to do a denial of service like what happened with Dyn DNS. If you don't know that story, type in Dyn DNS, Netflix, Twitter, and Amazon, and you'll find out this pretty popular, well-known outage in which these providers were using a third-party DNS provider that was attacked. As a result, all of these services appeared offline to the customer, and that's why Cloud DNS kind of stands above them all. It's 8.8.8.8 for those that are interested. So another thing that we want to do to handle this denial of service attack is to implement auto-scaling. In this case, we had a managed instance group, which was able to handle failovers, but now this is an auto-scaling instance group if we didn't call it out already. So in this case, we will be able to absorb the attack by adding additional servers if they've gone through all the other security mechanisms. So you've locked down the front end to prevent hackers from gaining access and potentially to sensitive user information. However, if they get around these protections, the back-end services are still vulnerable. So what kind of design changes can we make to the back end to provide that same defense in depth? Well, very similar to what we're already doing. First of all, we can isolate these servers. The assumption being they're on a public network. Let's go ahead and put them on an internal network. So this will now become internal load balancing. So we have a virtual private cloud and we have a private IP range. So this makes it a lot more difficult to get straight through directly from the network. You'd have to compromise these servers first in order to get to any of these back-end servers. Now, we can lock down the back end by doing private access. So if these servers are going to talk to the back end, we're going to create secondary NICs, which will exclusively reside on the private network. So this way we don't have to worry about punching holes or any securities from these public IP addresses. Again, we'll have one private access talking to another. We're also going to utilize private access to access some of the back-end storage. So if this is a cloud data store or GCS, we're going to access that exclusively over the private network as well. So going through our security checklist, right? The original design, well, we didn't have firewalls. Well, that was the design, but that's not how it would be in the cloud. We made it scalable and reliable, so this way, and we're not in separate zones, so we can isolate against fault tolerances, so there's some security in that. There was also assumed implicit trust between all components, so this is why we added load balancers, and we would also consider utilizing security accounts, IAM, maybe Bastion host to limit access, or even going strictly to serial console. Some additional considerations is we could start to encrypt our data using our customer supplied encryption keys. We can define specific operations. So if we didn't have them already, what is our process for compromise? What is the playbook? How are we going to communicate with everybody? Is our documentation up to date? Do we have the proper training? And have we isolated our users into the most restrictive groups possible that still allows functionality through IAM roles? And then defining testing elements. Do we have an external pen test capability? Can we walk through and try to break in and understand where there might be particular compromises in our security model?